All right, so we are on Unit 6, Day 4. Note, let's get started. There's a lot of objectives here that we're going to be covering. So make sure you print out your worksheet from Canvas, and then you can follow with me. The ones that are not starred, you can try them on your own. I will upload a key as well. All right, so let's start here. We are writing 68,690 in scientific notation. Scientific notation, the number, the decimal at the beginning has to be between 1 and 10. So basically, if you're writing this number here, the decimal is right there for a whole number. We're going to move this decimal so that this whole number is in between 1 and 10. So if we move it 1, 2, 3, 4 times, this number now becomes 6.8690. You don't have to put a 0 at the very end when you're talking about decimal, but you can. It's fine. It's still the same thing. But 6.869 times 10, and because this is a big number as opposed to a decimal, the exponent is going to be positive, and we moved it. We moved the decimal point 1, 2, 3, 4 places. It'll be to the positive 4 power. Okay. However many times you move the decimal place, that's what the exponent is going to be. If you're moving it from a decimal, then it's going to be a negative exponent there. Okay. So let's try this again. 496,800. Again, the decimal will be here. We're going to move it 1, 2, 3, 4, 5 places. So this will be 4.968. I'm not going to put the 2 zeros at the end. Times 10, we moved 1, 2, 3, 4, 5 times. Okay, so it'll be to the positive 5 power. And that's because this original number was not a decimal, it was a whole number. And that's when you know you're going to have a positive exponent. So if we're going down, let's go here to our next problem. You are going to write it in standard notation. At the top, we were doing it in scientific notation. Now they want it in standard notation, which means back to the original number here. So from here, and if you have a positive exponent, you know this number is going to be very large as opposed to small, okay, with the decimal. Positive exponent means a larger number. Negative exponent means a smaller number or decimal. So in this case, 9.686. We are going to move that decimal place 1, 2, 3, 4, 5 places to the right and add the zeros. Okay, so 968,600 and 1, 2, 3. That's where your commas go. So basically 968,600 is our answer there for standard notation. Let's go here for scientific. Again, this number has to be between 1 and 10. So how do we do that? We're going to move this decimal. Again, it's a very small decimal number. You know that the exponent is going to be negative, but we're going to move it so that this number is now in between 1 and 10. What do I mean? 1, 2, 3, 4, 5. So now 6.69 is between 1 and 10. What if I moved it here? I accidentally moved it there. It'll be 66.9. 66 is bigger than 10. You cannot have that in scientific notation. This number here has to be between 1 and 10. That's why we moved it so that it's 6.69, which is between 1 and 10, times 10 to the negative. We know where it's going to be a negative number because it's a decimal. So 1, how many did we move? 1, 2, 3, 4, 5. We moved 5, so it's going to be negative 5 there. Okay, got it? Good. All right, so now let's go to the next one. And the rest of these, remember, go ahead and try those on your own. The key will be in Canvas. The next one is standard notation. We're going to write this in standard. 7.89 times 10 to the negative 4, negative 4. So you know that this is not going to become a big number. This is actually going to become a smaller decimal number. So if we're moving to the negative 4, you're going to move 1, 2, 3, 4. Everywhere there's a bump, put a 0. So your number is 0.000789. Small number there. Got it? Good. All right, let's turn this around. Word problems, no run. But we're not running, not today. All right, so the total surface area of Africa is approximately 11,700,000 square miles. Write this number in scientific notation. So we're going to write this number 11700. And then there's 3 more zeros. 1, 2, 3. In scientific notation, again, this is not going to be difficult for us because we know that it has to be between 1 and 10. 1, 2, 3, 4, 5, 6. We could stop here, but 11 is bigger than 10, so we have to stop there between the ones. So it has to be 1.17. We do not have to put all those zeros after. Times 10. And this is a huge number, so we know there's going to be a positive. Okay? So 1, 2, 3, 4, 5, 7. I moved 7. Positive 7. That is your answer in scientific notation. An astronomer's infrared telescope is able to detect radiation with wavelength of this meters. Write this number in scientific notation. This is a teeny tiny small decimal number. Then you know that it's going to have a negative exponent. 1, 2, 3, 4 zeros. And then 196. So I'm moving this decimal point 1, 2, 3, 4, 5 places. So this number 1.96 is between 1 and 10 times 10. And like I said, I move 1, 2, 3, 4, 5 places. And 5 is going to be a negative 5 because the original number is a decimal. Got it? Good. Now, I am going to show you a nice little tips and tricks on the calculator that you can use in this class. I'm sure in Alex they'll do it. They'll show you the long version. This is going to be awesome. You're going to absolutely love this. I literally just learned how to do this on this calculator. I knew how to do it on the TI-83, but this particular calculator, this again, I keep saying this over and over again. This calculator is acceptable to use all the way up to pre-calc. You can use on test. So get one of these, okay? $12 at Walmart. So what I'm going to do is I literally just learned how to do this on this calculator. I'm going to just throw this in my calculator. So how do I do that? I'm going to put it in scientific notation. It is 3.2. And instead of putting times 10, in this particular calculator, go ahead and push the second key and then the little X to the -1, and it has a little EE on the top. That is the one you're going to push for scientific notation. And for this particular, after you hit the E, basically what it means is times 10. You're going to raise that to the 8th power, but you're not going to have to push the raise. You just push 8. Okay? So this is how you write 3.2 times 10 to the 8th in your calculator. And then again, I'm going to do it again for the second one. 2, I'm going to push second, and then that negative X to the -1 again, which is the EE on top, and then I'm going to push the 5 for the exponent, close that off, push enter, and it'll give me my answer, if you can see that. 6.4 times 10 to the 13th. It gives you the answer in the form that you're going to write it in. That's super cool. Okay, so you need your answer. It says write your answer in scientific notation. The calculator gives it to you in scientific notation if you put it in the correct way. So our answer is 6.4 times 10 to the 13th power. I'm very, very impressed with this. Very happy with that. And again, I just learned it. So yay, super cool. All right, so now let's go to this problem down here. Again, I'm going to throw this in my calculator, 5.3, and then I'm pushing the second, and then the X raised to the -1, and then -2 is my exponent there, and then 2.6, and then second E, and then it looks like -4 for that particular one. Okay, so when I push enter, wow, my answer didn't come out the way I wanted it to. But let's look at this. It has 0.0001378. That's how my answer came out on my calculator. I'm not sure why, but I believe maybe it's just too small of a number. But we have a way to figure that out. Our answer is going to be 1, 2, 3, 4, 5. We're going to move that 5 times here. So it's going to be 1.378 times 10 raised to the -5. We know that that is a small decimal. So since that's a small decimal, that is our answer. Maybe these calculators only give you the answer in scientific notation if the exponent is positive, maybe. So maybe if you had a negative exponent, it doesn't like that in the calculator. So maybe that's why. Yeah, it looks like your answers, when it's a negative exponent, it just gives it to you in a decimal. You got to move it over and make it into scientific notation. I'm still pretty happy with that. All right, let's move on to the next one because we know how to change stuff in scientific notation pretty quickly. All right, so now we're here, and we are going to use our calculator for that. This is what you're going to do for this one. You are going to put it in your calculator, parentheses, 6 second x1 raised to the 7th power, okay, looks like that, divided by parentheses. Remember to put these things in parentheses, even if they're not here when you're dividing. You want to make sure that it's in parentheses so that it can do whatever it's got to do on top and then divide it by whatever it has to do on the bottom. So this becomes 2 second, second that, 1, 2, and then that's the E, and then that's the 2nd power, so it looks like this, and then just enter there. Looks like it also isn't. I wonder why it's not giving me that. I thought I knew, but I guess I do not know what is going on. All right, so it did not give it to me inside the notation clearly, and I did it correctly, so let's write it out. Fine. 3, we know how to change it. 1, 2, 3, 4, 5 zeros. And we're just going to move it. 1, 2, 3, 4, 5 times. 3 times 10 to the positive 5 power, because this is a big number as opposed to decimal. Okay? I wish it just did what I asked it to do. Let's try the next one. All right. We're going to put it in correctly. We're going to put in 8.5. Get that E to the 9th power, divided by, and then we'll have 3.4. It's the E again, and it's to the -10th power. Push enter. Oh, it did do it this time. I'm not sure what the rhyme or reason is, but listen, look, yay! 2.5 times 10 to the 19th power. So 2.5 times 10 to the 19th power is your answer there. We got that one using our calculator with that nice little tool, okay? So hopefully that works for you, and if it doesn't, if it comes out to be a whole number, we know how to change that in the scientific notation. Got it? Good. All right, so now on these couple, it asks you what are the degree and leading coefficient of the polynomial. So when it's asking you for degree, what you really do need to pay attention to is where you have the pluses and minuses, because the pluses and minuses, they determine when the term stops. So in this case, because that plus here, these pluses means that this is one term, this is a term, this is a term, this is a term. In between those pluses and minuses, those are representing terms. So, and that is important in this, because when you're talking about a degree, the degree is basically the exponent. What is the exponent? So in this one, the degree would be 4 in this particular term. In this term, there is no exponent, so the degree is 0 because it's just a 9. Here, the exponent is 2, the degree is 2. Here, the exponent, there is no exponent, but it has y. It actually has a variable. In this one, it did not have a variable. It just had a number 9. It had no exponent. That has a 0 degree. But in this case, it has 20y, and the y is actually there. The variable, meaning that the exponent is actually 1. Even though you don't see it, we know that from earlier, that the exponent is 1, so the degree would be 1. So what is the highest degree? The degree of the entire polynomial or the entire problem is the degree of the term with the highest degree. So the whole term's degree is 4 because that's the highest degree. So 4 is the degree. So if they ask you for the degree here, we'd say 4. And they say, what's the coefficient of the polynomial? That means what's the number in front of the one with the highest degree? If there's nothing in front, it's 1. But in this case, it's -10. So the coefficient is -10 there, okay? And we're definitely going to be continuing on that. All right, I have to stop for a minute. Okay, so let's move on to the next problem here. All right, so again, paying attention to the pluses and minuses, those are where your terms stop. So our term 15u is a term, 4u to the 8th is a term, u to the 9th is a term, 9 is a term. Each one of these are terms. Let's look and see what the degree is for each term, which means what is the exponent. The exponent here, 15u, has an exponent of 1. U has an exponent of 1, the degree is 1. 4u to the 8th, the degree is 8. U to the 9th, degree is 9. 9, no exponent, no exponent, and no variable, 0. When it's just a number, the degree is 0. So the highest degree here is 8. So our degree on what they're asking you for would be 8. And the coefficient, meaning what is the number in front, okay? What's the number in front here for the 8? Oh, look at this. Look at this, guys. Our highest degree is 9. What am I talking about? Degree is 9. Sorry about that. For the whole polynomial, the degree is 9 because the highest degree is 9. So the degree is 9. The coefficient in front of this u to the 9th, there's no number in front of it. So what did I say earlier? The coefficient is going to be 1. Okay? Good. And that's for this one and that one. All right. So here it says, give the degree of the polynomial. So all they're asking you for is degree in this particular situation. Again, separate those terms so you know this is a term, 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 term. So in this particular situation, as you see, this whole thing is one term because we're separating the terms by pluses and minuses. So this whole thing is a term, the 4 is a term, the 5u is a term, and then this whole situation is a term, okay? And now when you see that all of this right here is one number or term together, then you have to add those exponents. When you have multiple exponents in one term, you have to add them, okay? So in this particular situation, 6x to the 6, y to the squared, and w to the 6, you're adding 6 to 6, I believe that's 14. Yeah, 6 plus 6 is 12, plus 2 is 14. This 4 has a degree of 0. 5u, again, it has a 1 degree because of the u to the 1 power. And then the 8 and the plus 7, because again, these are one term, that's going to be, I believe, 15. Okay? Now, that you have all that, the highest degree is the degree of the entire polynomial. So the degree of the highest, you do not add these. Once you find the terms and figure out what the degrees are for the terms, you don't add all of those together. You just take the highest one. So the degree of the highest one is the degree of the entire polynomial. So in this case, it's 15, okay? Because we had that 8 plus 7. Got it? Good. All right, again, separate the terms. Term, term, okay? So this whole thing is a term. This whole thing is a term. This is a term. This is a term. Okay, we're separating, we're basically circling out where the pluses and minuses are, and then before it stops, the whole thing in front or in between is the term. So this whole thing is a term, this whole thing is a term. As soon as you see that plus and minus, that's where that term stops. Here, this degree is 3 plus 2, which is 5. Okay, this degree, do not forget this 1 here, even though it doesn't have one, is 8bu squared w squared. Don't forget that 1. It's going to be 2, 2, and 1. That is 5. This degree here, u to the 6, is 6. This does not have a letter, so it is a 0. When it's a whole number, it's going to have a degree of 0. Okay? No exponent, no variable. So your degree here is the term with the highest degree, which is 6. So our whole degree of our polynomial is 6 there. Got it. All right. Now let's go here and we're going to simplify. When you're simplifying these two, you're not combining like terms yet. First and foremost, when you have something in the middle, you need to get rid of it. In this particular case, when it's a subtraction sign, you're going to distribute that subtraction. Basically, you're going to change every sign here. If it was a plus, we could just drop it and move and then combine like terms. But in this case, since it has a minus in between, we're going to distribute. This becomes negative 6x squared. This now becomes, when you distribute the negative, it becomes positive 4x. This becomes negative 7. Okay, now that we've done that, now we can combine like terms. We have 3x squared and negative 6x squared. Okay, that when you combine those, that becomes negative 3x squared. The 4x doesn't have a partner, and then positive 1 and negative 7. I'm going to bring the 4x down. Positive 1 and negative 7, negative 6. So now I combine like terms, and I got that as negative 7. Okay. Again, try that one on your own, although that's a plus in the middle. Pretty simple there. But let's try here. So when you have that plus in the middle, it makes life much, much simpler because then you're not going to have to distribute anything. You can just take this u, 9u squared plus 4u plus 8 plus, when you have the plus in the middle there, you're not going to do anything with it. You'll just leave this alone. But when the negative's in the middle, you have to distribute like we did the first time. Okay? So this now becomes negative 2u squared. This becomes plus 4u. And that becomes minus 2. So all the negative does is change signs of everything. Okay? Changes everything's sign. I'm not sure that's clear. Let me see. Got it? So now let's combine in third. 9u squared. I'm not sure why this is okay. All right, so 9u squared. Then we'll have plus 6u squared minus 2u squared. So all of those have the u squareds on them. That's why we are I'm trying to get this working. Okay. All right. That's why we're combining those. So 9 plus 6 minus 2. Okay, 9 plus 6 minus 2 becomes 13. So that would be 13u squared. And then I have positive 4u, negative 4u. Those kind of cancel each other out, right? And then positive 4u. So what's left over is positive 4u. And then 8, negative 9, negative 2. 8 minus 9 minus 2. That becomes what? Negative 3. So though when I combine my terms, that is what I get. Got it? Yes. All right. On to the next page. The start, again, this is the same concept. A little bit more difficult because of the terms, and we'll talk about that once we get to it. So we do have to distribute that negative. Let's keep the first the same. 3xy squared plus 2 minus x squared y squared minus 5x squared y plus 4x squared y squared. As you see, I changed that sign there. Okay. Now we're going to be combining like terms only. And this is where it can get tricky because look at this 3x squared xy squared and 5x squared y. These are not like terms. This x does not have a square and that one does. This y has a square, that one does not. You cannot combine unlike terms in this case. So those, believe it or not, they're just going to stand next to each other. They are not like terms. So they'll stand. But these two are negative 1, although that doesn't have a 1 there, it's understood. Negative 1x squared, y squared, and positive 4x squared, y squared. So basically 4 minus 1 is positive 3. X squared, y squared. Okay? And then the plus 2. So these ones right here, we just brought them straight down. The positive 2 also doesn't have a partner, and we just brought it down at the end. So your answer would be this. Okay? So again, it can get tricky when they try to put ones that are similar, but they can't just be similar. They actually have to match for the like term. Okay? So for this direction, it says use the distributive property to remove the parentheses, simplify your answer as much as possible. Let's go ahead and do that. We're going to distribute, and then we're going to try to combine like terms if we can. It doesn't look like we can, but let's try it. So if you remember from exponents, okay, this one is, let me see if I can turn this light off. Maybe the light is making a glare or something. Is that better? Yeah, it's a little better. Seems like the light on my camera has a little glare. So let's look at this. We're distributing. Basically, we did this with exponents. You're multiplying the numbers, adding the exponents because they have bases that are alike. Okay. So this one, if you can read it, and hopefully you have this printed out, or you're looking at this on another on your Canvas shell, but you have to multiply the numbers. 9 times 3 is 27, and then b to the 6 and b to the first power. Basically, you're adding those exponents. That becomes b to the 7th. Okay, plus, and then 9 times 10 is 90, and let's go b to the 6th plus b to the 7th, times b to the 7th. When you add those exponents, 6 plus 7, you get 13, plus 3 times 9, I'm sorry. 3 times 9 is 27, and then b to the 6 is by itself, so you just leave that alone. Doesn't look like there are any like terms here, so that is what you'll do. Many times they want you to put the exponent with the highest degree first. It goes from the highest degree to lowest degree. So if they want that, then that 90b to the 13th has to be first, and then it's going to be the 27b to the 7th, and then it's going to be the 27b to the 6th. Depending on what they want. They want in standard form, it's had the highest degree first. So let's look at this one. This particular one, the number is behind, but it's still the same thing. You're just going to distribute, multiplying the numbers, adding the exponents. So 2 times 3 is 6, c to the 4 plus 2 is 6, minus, sorry about that, 2 times 7 is 14, and then add 4 and 3 and get 7. So this would be your answer here. And again, the standard form, if they wanted it, please take the sign with it. So you wouldn't just flip those, which what it would be would be negative 14c to the 7 plus 6, 6c to the 6th power. Okay, so the sign in front of it belongs to it. So if you move it, you have to take the sign in front of it with it. So this would also be the answer, and this one would be in standard form because the degree is higher. The highest degree goes first. It goes from highest to lowest degree. Okay, so let's move here. And again, you're distributing, multiplying the numbers, adding the exponents, nothing big, nothing hard. And if you have to combine like terms, then you should. In those cases, you didn't. Let's do this again. So 7 times 5 is 35. With the x's, only the x's you add the exponents because they have the same base. So x to the 10. Y in this case does not have anything with the same base. We will leave it alone. Plus 7 times 2 here is 14. Add the exponents with the x's, x, and then 4 plus 2 is 6. With the y, this is a 1y and a y to the 5th. So this becomes y to the 5 plus 1, which is 6. Then same thing. 8 times 7 is negative 56. And then x, there's no x. So you leave x to the 4th alone. It just stays x to the 4th. And then the y to the 1 plus y to the 5th becomes y to the 6th. And it doesn't look like there's any like term. If there are, you have to combine them. But in this case, there is not. Got it? All right. So let's move on. This one is it says multiply and simplify your answers. All you're going to be doing here is called FOIL. Okay. You're going to be multiplying u times u times negative 7. Please remember, if there's a minus in between, that means that second number is negative. This case, this is a plus, believe it or not. Kind of hard to read. 2 times u, and then 2 times negative 7. So let's start this. U times u is u squared. We should know that because same base, you add the exponents. 1 plus 1 is 2. U times negative 7 is negative 7u. Same thing here. 2 times u, positive 2u. 2 times negative 7, negative 14. Okay, so that's what I have there. I'm now going to combine my middle terms, my like terms. This one, u squared doesn't have a term. Negative 14 doesn't have a like term. But the negative 7u and a positive 2u, they are like terms. So I'm going to leave u squared alone. 7 plus negative 7 plus 2 is negative 5u. And then leave that negative 14 alone. And that is my answer. That's what I'm going to be getting. On the opposite, really, of factoring, which is coming up as well. Okay. All right. So I got that one done. We're on the last page here in your Unit 6 Day 4 notes. And again, you're going to be foiling. So we have 5x times 7x, 5x times w. Let's do that one first. 5x times 7x, again, to multiply the numbers, 35. X's bases are the same. Add the exponents. 1 plus 1 is 2. So this is 1 and 1. 1 plus 1 is 2. 5x times w. With that one, it'll be 5xw. Okay, there's nothing you can really put together. There's no numbers, and the letters are, the bases are not alike, so you can't put them together. Let's do this one. 3w times 7x. We can multiply 3 times 7. That becomes 21. But the x and w, nothing you can do. Just set them next to each other. And then we're going to multiply 3w times w. And that one is going to be 3w squared. And we know bases are alike. You add the exponent. W times w is basically you add 1 and 1. And that's how we got w squared there. Okay. Combine like terms. Those middle terms are like terms. 21xw and 5xw. So 35x squared, okay, plus what? 26xw plus 3w squared. There's nothing going on there. This is your answer. Once you combine like terms, looks ugly, but that's just how it is sometimes. All right, so let's move here. Okay, 3z times 3z, again, multiply the numbers. 3 times 3 is 9. Z, same base, add the exponents, z squared. Then you have 3z times negative 7x. 3 times 7 is 21. And then we have x and z. There's nothing you can do with those two because they are two different bases. Here is going to be 7x times 3z. That's oops, I got it wrong there because it's 3z times negative 7. That's negative 21. This particular one is positive 21xz. Okay? And then if you multiply that, 7 times 7, and then it's a negative 7. So 7 times negative 7 is negative 49x squared. Okay? Combine those middle terms, negative 21, positive 21x z. These are like terms. These are not. Actually, they cancel out. One's negative, one's positive. This now becomes 9z squared minus 49x squared. And those are not like terms. We can't combine them. Got it? Good. Rewrite without parentheses. In this particular case, I'm just going to write this out twice. Okay? Just to make it easy for myself. And then I'm just going to FOIL it. W times W is W squared. And the more you do it, you'll get used to it. W times negative 6, negative 6W. Negative 6 times W, negative 6W. And negative 6 times negative 6 is positive 36 because two negatives, when you multiply, they become positive. Combine these middle terms and don't feel like you have to cancel them out. You do not. They're both negative. You would cancel out one positive, one negative. So this becomes W squared minus, because you're adding really there. When you combine it like terms, you're adding and subtracting. You are not multiplying. So it's going to be negative 6 plus negative 6, which is negative 12W plus 36. So our answer there is W squared minus 12W plus 36. All right, let's try it again. Here, 4 plus 2y, and they want you to square it. So you're multiplying a number by itself. 4 times 4 is 16. 4 times 2y, positive 8y. 2y times 4, positive 8y. 2y times 2y. Multiply the 2's, plus 4, and then the y's times y is y squared. Combine. As you can see with these, you start to see a pattern. That's why I love mathematics. Patterns are everywhere. Once you start to see a pattern, then you can figure it out. As you see, the middle terms are usually the ones that you can combine, and the outer terms you cannot. Usually it is like that. So this will be 16 plus 8y plus 8y, 8 plus 8, 16y. And when you're adding, you do not square this. Remember, you're just adding. So you do not. The only time you square is you're multiplying, but you're not. You're adding. Plus 4y squared. If you had to write this in standard form, you know you'd write the 4y squared first because it's the highest degree. Plus 16y plus 16. That would be in standard form. Okay? And remember, the sign in front of it belongs to it. So if it was a negative, it has to go with it. Got it? Very last one here. First and foremost, I would distribute the negative. So you distribute this negative first. Okay? Order of operations, whatever. I would distribute that negative first. So it becomes negative 6y minus 5. Then go ahead and FOIL that. Okay? Now you can FOIL it. So negative 6 times 4y becomes negative 24y. Negative 6 times negative 3, positive 18y. Then I multiply negative 5 times 4 is negative 20y. And then negative 5 times negative 3 is positive 15. Okay? Again, Where did I mess up, guys? Oh, right here. That's the squared because it's negative 6y and positive 4y is negative 24y squared because they both have y. So you know I have to combine the exponents. Okay, multiply the exponents meaning adding. I mean multiply the with the same basis is adding exponents. So when you're adding, like right here, you do not worry about the exponents. You're just going to add the numbers and keep the letter. So this becomes negative 24y squared. And then I have, what is it, positive 18, negative 20. That becomes negative 2y. And then plus 15. That is my answer there. Okay, once I combine my terms. All right, so that is Unit 6, Day 4 notes. Done.